Hello guys, in this video series we are going to create an Uber Eats clone, but instead of creating an app for restaurants, we are going to create an app for gyms. And instead of delivering food, users will be able to deliver exercise equipment. So in order to create the backend of our application, we are going to use Node.js, NestJS, Prisma ORM, and PostgreSQL database. And in order to interact with the database, we are going to use this dbeaver client. So make sure you have these things installed on your system. Once you have Node.js installed on your operating system, you can use this command to install the NestJS CLI. So open up a terminal window. I'm using Arch Linux and ZSH shell, but you can use whatever shell and operating system you like. Everything will be same as long as you have Node.js installed. So no matter you use Windows or Mac OS or any Linux distribution, everything will be same. Right now I'm using these versions of Node and npm. So go ahead and create a directory for our project. And inside this directory, use this command to create a new NestJS project. Name it whatever you want, then press enter. Now I'm gonna use npm package manager. Now go inside this project directory and launch it in your favorite code editor. I'm gonna use Visual Studio Code. Let's move our code editor to another workspace. As you can see, NestJS has generated a lots of files in our project directory. So this main.ts file is entry point of our project. And as you can see, it listens to port 3000. If you're familiar with Java, you can think of this file as the main class or main method of our project. It has also generated an app.service and app.controller file for us. The app.service file will communicate with the database, and the app.controller file will communicate with the outside world. And this app.module file will bring the service and the controller together. Now, if you take a look at this package.json file, you'll see that it has generated a lot of scripts for us. So in order to run this app, we are going to run start:dev script. So go back to your terminal and execute this script. Now as you can see that our app has compiled successfully. So go to your browser and go to localhost :3000. As you can see, our app is up and running on port 3000. Now let's make some changes to this function and make sure that live reload is working. So make some changes and save this file. Now go back to your browser and refresh this page. As you can see, live reload is working. So before we go any further, let's commit this code. So if something goes wrong, we'll be able to revert back to this stage. Now, in order to create a GraphQL API, we are going to need some dependencies. So open a new terminal window, go to your project directory, and use npm to install some dependencies. So we're gonna install nestjs/GraphQL, the latest version of GraphQL, and Apollo Server Express dependencies. If you're using Fastify, then you'll use Apollo Server Fastify, but I'm using Express behind the scenes, so I'm gonna use Apollo Server Express. So I'm gonna remove these spec files because we're not going to write unit tests for now, but in a later video we'll learn more about unit testing. So then we'll create these files again. But for now I'm gonna remove these files. And also remove these imports from the module file. Now as you can see that our app is not rendering that message anymore, but that is to be expected because we have deleted those files. Now in order to create gym functionality, we are going to need a new module. So go back to your terminal and use NestJS CLI to generate a new module. Type nest generate module followed by module's name. I'm gonna generate a module named gym. As you can see, our module has been generated. Now go back to your terminal and generate a service in this module. We are also going to need a resolver. So our service will communicate with the database and resolver will communicate with outside world. As you can see, Nest CLI has automatically imported the service and resolver in the module. Now I'm gonna delete these spec files because we don't need them. Now in order to work with our gym entity in the memory, we are going to need an entity file. This file will serve as a GraphQL object type. So I'm gonna create a new folder named entities, and inside this folder I'm gonna create a new file named gym.entity.ts. Now annotate it with object type annotation and create a new TypeScript file. Now inside this file we can add fields for our gym entity. So annotate fields with this field annotation and specify fields type as an arrow function. So I'm gonna create an ID field that will serve as a unique identifier. Now create another field for name, another field of type string for address, another field for yoga classes. This field will let the user know that whether a particular gym has yoga classes or not. And one last field for owner's name. We'll keep adding new fields as we move forward, but for now these fields will suffice. Later we'll replace this owner field with its own object type. For now we're gonna use it as a string. Now go to the gym service and create a new async function. This function will return all gym entries from the database. Add gym entity as a return type, and here we're gonna write code to communicate with the database. Now in order to communicate with the database, we are going to need an ORM. So go back to your terminal and add Prisma ORM as a dependency. Now we have installed the Prisma ORM. Now use npx prisma init command to initialize the Prisma ORM. Now go back to your editor. As you can see, it has generated a new folder and Prisma file for us. In this prisma.schema file, it has configured PostgreSQL as our database and is collecting database credentials from this .n file. So open the .n file and add your database credentials in this URL. So add your username, password and database name. Now I'm gonna use Gbeaver client to create a new database. Make sure your Postgres server is up and running. Create a new database connection. Give your username and password and press this button. Now create a new database. Make sure its name matches the name in the URL. Before you go any further, make sure that the database name matches the name in the URL. Now inside the schema.prisma file, we're gonna write models for our database. So we're gonna basically translate this entity file into a Prisma model. So create a model named gym. Prisma has its own syntax which is different from TypeScript. Now create an ID field of type int and annotate it with default, auto increment and ID annotations. Create a unique field for name so the database won't allow duplicate entries. Another field for address, a boolean field for yoga classes, and a string field for owner. So now in order to generate tables and columns from our model, we need to run database migrations. So go back to your terminal window and run database migrations using this command. Name it whatever you want and press enter. Now if you take a look at our database, you'll see that Prisma has generated corresponding tables and columns for us. So now that we have our table and columns, we can write TypeScript code to communicate with them. But in order to communicate with them, we are going to need Prisma Client. So go back to your terminal and install it as a dependency. So now in order to initialize the Prisma Client, we are going to generate a new module. So use Prisma CLI to generate a module named database. Inside this module, create a new service. As you can see, our module and service has been generated. So go to the service class and extend a class named Prisma Client. And don't forget to import it from Prisma library. Now implement onModuleInit and onModuleDestroy interfaces. Now override abstract functions from these interfaces. We need to override onModuleInit function and onModuleDestroy function. So override these two functions. Now in order to make this database service available to other modules, we need to export this service. So go back to your module file and add this service in this exports array. Now we're going to import this service in the gym module. Finally, inject this service in this gym service. In order to perform dependency injection, we are going to pass this service in this constructor as an argument. So create a new constructor and pass database service as an argument. Now finally you can write code to communicate with the database. So the Prisma ORM has automatically generated corresponding classes for our models. All we have to do is call the appropriate class from the Prisma client. So in order to get all database entries, we are going to execute findMany function on Prisma client without any argument. This function will return an array of gym entities. So change the return type to an array of gym entities. Now our database is connected. Now in order to write a GraphQL query, go back to your resolver and create a query annotation. But before that, annotate this resolver properly. Now create a query and specify that this query will return an array of gym entities. Now create an async function that returns a promise of gym entities array. Now all we have to do is call the function from our gym service. So in order to do that, we need to inject that service in this resolver. So create a constructor and pass that service as an argument. Now call the function we just created from this function. Now we have successfully wrote a GraphQL query. But before we run this application, we need to declare GraphQL module in our app module. So go to this app.module file class and declare GraphQL module in its imports. Make it available for the whole application, and as an argument we need to pass a path to the schema file. So we'll be able to see raw GraphQL schemas NestJS is generating behind the scenes. You can skip this step, but then NestJS will generate schema file in memory. So if you want to read the schema file, we need to specify a path for this file. I'm gonna store it in source folder. Now if you go back to the browser, you can see that our app is not working. So let's take a look at terminal window. As you can see, it's throwing an error. Let's kill this process and run it again. As you can see, it's still throwing an error and it's saying that it can't resolve dependencies of the gym service. So there's only one dependency of the gym service, and that is database service. So perhaps we didn't properly import the database service. As you can see, we have imported the database service, but we were supposed to import the database module. So let's correct this mistake. Replace database service with database module. Now replace this import. Now our app is up and running. Now go to localhost 3000/GraphQL. Now as you can see, our GraphQL API is up and running. Now we can write a GraphQL query to interact with the API. As you can see, it's returning an empty array, which means our API is connected to the database. Now let's manually add some data in the database and see what happens. So in order to do that, we can use a client named Prisma Studio. To launch Prisma Studio, go back to your terminal window and type npx Prisma Studio. Make sure you are inside the project directory. As you can see, it says Prisma Studio is up and running on localhost 5555. Let's move it to another workspace. Now go to localhost 5555, and as you can see, our Prisma Studio is up and running. Now use Prisma Studio to add a record in the database. Give it some random name and address. Here I'm gonna type my former roommate's name. Now create another entry. Now hit Save Changes button to add this data into database. Now go back to the GraphQL playground and run this query again. As you can see, it's returning data from our database. Now in order to write GraphQL queries, I'm gonna use a better and more professional GraphQL client known as Apollo Studio. So go to Apollo Studio's website and sign up using your credentials. Create a new graph, give it whatever name you like, and give it the endpoint to your GraphQL API. Now press this button. Open a new tab. As you can see, it has automatically detected our GraphQL query. Now add this query to the editor and choose some fields. Now hit this button to run this query. As you can see, Apollo Studio is easier to use than GraphQL Playground. Let's go back to Prisma Studio and add a new record. But as you can see here, it's not returning owner's name. So perhaps it's a bug in Prisma Studio. Let's try once more. Now it's working as expected. Now we have successfully connected our database to the API. Now let's develop functionality to create new database entries. So go back to your code editor. In order to develop create functionality, we are going to use data transfer objects. So create a new folder named DTOs. Inside this folder, create a new file named create_gym.dto.ts. Now this data transfer object will be almost identical to the entity type with the exception of ID field. So go back to your entity file and copy all these fields. Now annotate this DTO with input type annotation. Now create a new TypeScript class. Now inside this class, paste your fields. And don't forget to import the field annotation. Now that we have our data transfer object, let's go back to service and create a new function to create database entries. So write an async function named createGym. This function will receive the data transfer object we just created as an argument, and it's going to return gym entity. Technically, we are not required to return gym entity, but we are doing this to make things easier for front-end developers. So when a front-end developer runs a query, so he will know that he has successfully created a gym entity in the database. Now, in order to create an entry, we are going to use create function on the Prisma client. This function will receive a JavaScript object as an argument. Inside this object, simply spread the object you received from the user. Now go back to the resolver and create a new mutation. In order to create a mutation, we are going to use mutation annotation. Now specify that this mutation is going to return a gym entity. Create an async function and specify that this mutation is going to receive an argument by using @args annotation. Now give it a descriptive name and put this argument in a variable of type data transfer object we just created. This function will return a gym entity as well. Now all we have to do is call the function we just wrote in our gym service class. Now pass this argument to the service. So now we have successfully created our mutation. Let's go back to Apollo Studio and try to run this mutation. Open a new window. As you can see, it has automatically detected our mutation. Now add this mutation to the editor window. Choose some fields and give it some random data as an argument. Now as you can see that it's yelling at me because I've mistakenly passed a string instead of a boolean. So let's correct this mistake. Now it's working as expected. Now if you try to run this mutation again with the same name, it will throw an error. It's because we explicitly mentioned in our model that we don't want duplicate entries for our name. So let's try to change the name and run this mutation again. As you can see, now it's working. Now let's do it once more. Now let's run our query again. As you can see, it's returning all the new database entries. Now go back to your code editor and take a look at this data transfer object and entity file. As you can see, they're almost identical with the exception of the ID field. And there's lots of duplicate code. So in order to solve this problem and remove these duplicate fields, we are going to use a feature of NestJS known as map types. So remove these fields. Now extend a class named omit_type. Now this class can help us to inherit the fields of another class. So pass gym entity as a first argument. Now in the second argument we are going to pass an array. And inside this array we can specify the fields we want to omit. So in this situation we are going to omit the ID field. Now this class has inherited all the fields with the exception of ID field. And as you can see that there's no duplicate code. Now if you try to run this application will crash. It's because the gym entity is an object type and we are inheriting its fields in a class of input type. So in order to solve this problem, we are going to pass input type as a third argument. Now it has compiled successfully. Now let's try to run our mutation once more to see if it's working. As you can see, it's working as expected. Now that we have successfully developed the create functionality, let's develop functionality to update a database entry. But before we do that, let's commit this code so if something goes wrong, we'll be able to revert back to it. Now, in order to create update functionality, let's create a new data transfer object. So create a new TypeScript file named updategym.dto.ts. Annotate it with input type annotation and create a new TypeScript class. This time we are going to extend a class named partial_type. This class will help us to inherit all fields from a parent class, but it will mark them as optional. So the client will be able to update whatever field it wants and leave the other fields as they were before. So we are going to inherit this other DTO. And now we have created our new data transfer object. It has inherited all the fields from this other DTO, but it has marked them as optional. Now go back to the service file and create a new function to update the database. I'm gonna name it updateGym. It's going to receive an argument of updateGymDTO and it's going to return a gym entity. Now, in order to update an entry, we are going to execute update function on our Prisma client. This function will receive two arguments. As a first argument, we are going to pass a unique identifier. In this situation, our unique identifier is the ID field. So we are going to receive ID from the user and hand it over to the Prisma client. Now, as the second argument, we are going to spread the user input. Now, go back to the resolver and create a new mutation. This mutation is going to return a gym entity. Now create an async function and declare that this function is going to receive two arguments. As a first argument, we are going to receive the unique identifier, and as the second argument, we are going to receive an object of type updateGymDTO. Now call the function from our gym service and hand it these arguments. Let me fix this syntax error. Let's make sure that everything is fine in the service class. Now go back to Apollo Studio and try to run this mutation. Open a new tab. As you can see, it has automatically detected our mutation. Now add this mutation to the editor. Now choose these arguments and choose some fields. Now run this query with ID field to find out IDs of our database entries. Now let's say we want to update this database entry that has ID of 1. So pass this ID as an argument and pass the field you want to update in this second argument. Now run this mutation. Now as you can see, the name has been updated and everything else is same. Now let's try to update another entry. Let's say we want to update this entry with the ID number 2. This time we want to update its address. Now run this mutation. As you can see, the address has been updated and everything else is same. So in this video, we learned how easy it is to create a GraphQL API with NestJS and Prisma ORM. We also learned basics of NestJS and GraphQL. So in the next video, we'll inshallah learn about authorization and authentication. And we'll also learn how to encrypt our passwords and store them in the database. So see you in the next video inshallah.